everybody. How's it going? So yeah, as Jovan said, my name is Stephen Andrews. Today I want to kind of talk to you guys about making blockchain friendly. Because let's face it, if we want to see mass adoption, we need things to be more seamless and easy for new users. So firstly, a bit about me. I flew in all the way from New Zealand, so I apologize for the accent. And no, I'm not going to do a haka today. I'm a long-time Tezos supporter and I'm a community developer. Last October, we received funding from the Tezos Foundation to establish TezTech Labs, and our focus and mandate is to help to grow and develop the ecosystem. So we've done this through a multitude of projects. So we've got the TezBox wallet. We released Fee, which is a high-level smart contract language for Tezos. We've also done baking tools, guides, other resources, and other projects as well. Secondly, I'm also a board member for the Tezos Commons Foundation. So over the last year, we have done a lot to help support and run and grow some of the community events and meetups. We've partnered with Zastrin to release an online course for new developers. And we are currently working with other parties like the Trust Wallet to help with Tezos integration in general. And then finally, I'm also the CTO for Viaz. We are a peer-to-peer lending system based on blockchain, being built on Tezos. We just established a fiat banking partner with Bank Frick in Liechtenstein, and we continue to grow and innovate our smart contract, exploring new and innovative ideas as well. So yeah, let's get started. So firstly, why Tezos? For me, there are three main reasons. The first one is the consensus mechanism. So liquid proof of stake. This has advantages over proof of work as it doesn't just consume and use a ton of electricity. It also realigns the incentives of the people who validate the network with those of the stakeholders. Liquid proof of stake gets the liquid part from the fact that there isn't a fixed amount of validators on the network. For example, EOS, that forces a maximum of 21 validators at any one time. So like I think what Awa said before was that we have about just under 500 current bakers on the network, so that's huge. The second point that I love about Tezos is the smart contracts and the fact that they are formally verifiable. That means we can generate formal proofs that prove the correctness of our code. When you look at what happened with Ethereum, where you can potentially lose a ton of funds from a simple bug within a smart contract, it makes a lot more sense to use a formally verifiable smart contract language. And the final thing, and probably the biggest thing for me, is on-chain governance. Stakeholders with Tezos are empowered to grow and to adapt the Tezos protocol. And we as the stakeholders have a say in the direction we want the protocol to move in. That means any new and emerging technology we can easily adopt and integrate with the Tezos protocol. These three properties make Tezos an eco-friendly, secure, and future-proofed blockchain, which to me is an amazing piece of technology. So back to the new users. So usually, users require a wallet to use the blockchain. The problem with that is there are a lot of issues that, as a wallet developer, we've identified. We get emails daily from people who have issues. Most of the time, it's a user-based issue. So the first one is there's a bit of a learning curve to cryptography and public key cryptography. It's not like traditional username and password type systems where you can easily restore or reset your password if you need to. Because of this, a lot of new users don't understand the security measures that they need to take or the consequences that can occur if a mistake is made. Secondly, the whole thing about decentralized wallets is that you own your private key. The downside is that you own your private key. You know, if you lose that, you lose all your internet money. Your magic internet money is gone. A lot of new users and even some experienced users get trapped by this And in my opinion, it's a huge issue that needs to be addressed and resolved. Finally, it comes down to persistence. If your address is ever compromised, you can never use it again. For example, if you shared your Tezos address with your friends and family to make payments to you, and then you get hacked, you need to go and create a new address and inform everyone that you've shared it with to use your new address instead. Imagine changing your name every 2 weeks and then sending an email to all your friends announcing a new name. For me, persistency is an issue that needs to be resolved. So how can we do that? Well, with smart contracts. So smart contracts allow us to deploy and execute immutable logic on top of a blockchain. That means code that can't be tampered with. This provides us with the ability to do the following things. Firstly, we can add a mechanism to allow the rekeying of an address. That means changing the private key that controls an address, similar to changing the locks on your doors. So if you ever lost your private key, this mechanism will allow you to map it to a new one. Which leads into point number 2. We need a process that only allows the owner to do this. So we've identified a recovery process that defines rules that govern and determine the way to prove ownership of an address. This can be all done on the blockchain using smart contracts. Finally, because we're working with smart contracts, things become more than just a wallet. When you think about it, a wallet stores data, that's your balance, and it executes functions by increasing your balance when you receive funds and decreasing your balance when you spend them. With smart contracts, we can actually store any amount of data we want, and we can execute infinitely more types of functionality. For example, direct integration and communication with other on-chain contracts. So what have we been building at TezTech? So today I want to announce one of our projects, which is Sona. It's a self-sovereign identity built on top of Tezos. What this does is it provides you with a unique and persistent address. So when you create your account, you'll be given a single address, and you have the ability to recover that address if you ever lost control of the private key controlling it. This then works into the next point about Sona, is that we can now work with friendly name services. Instead of having an address that starts with KT1 followed by 33 other random characters, we can have a friendly name like Steven at Sona. It's essentially how domains and DNS works. Nobody goes around remembering an IP address. We access websites through domains. This is an example of how the internet has adopted a technology to improve usability with new users, and any users in fact. And it's something that blockchain can mimic and should mimic. Next up, we're developing Sona as a mobile app for iOS and Android. And what we've noticed is that a lot of these devices are starting to be built with hardware security modules on the device themselves. That means essentially in future, mobile phones can become a mobile hardware wallet. You can even secure them with biometrics. So if you ever lost your device, you can easily recover it and remap it to a new device, and you don't have to be compromised by the fact that you could get hacked. It's impossible to extract a private key from a segregated chip. This also allows us to work with private data. Instead of storing your private data on a centralized server, we can store that all on the same device. Users can create a backup, they can encrypt it, and they can download it, store it on a pen drive, or on Google Drive, or anywhere else. We also want to partner with backup services who can keep an encrypted backup copy for you, but that's an option that users can choose. In the event that you need to restore your account, you can do so easily simply by restoring that backup. This then leads on to, and what that does is it promotes data control. You get to control your private data, who you share it with, and who you want to grant access to that private data. Which leads on to on-chain verifications. Imagine working with a KYC partner who, after verifying your identity, they provide an on-chain attestation to the validity of your ID. Therefore, in future, when you're working with apps that require a KYC process, they can trust this on-chain verification, and you don't have to share your photo ID or any other private and personal data with them. This again promotes data control and providing users with the access and empowering them to decide how they want to share their data. So I also want to quickly talk about the key recovery process within Sona, because for us, it's one of the biggest things that we've been working on. So there's three attributes of this system. Firstly, when you create your Sona account, you select recovery questions and answers. If you ever lost control of your account, you can simply go forward with use a new device and restore your account, answering the questions that you've set. This will lock your account, so then anyone who has access to it is pretty much locked out until the recovery process is complete. The next stage is gatekeepers. Gatekeepers approve a recovery request whenever you perform one. Gatekeepers come in three types. Firstly, we have friends and family, who is anyone with a Sona ID that you trust to verify your identity. If you're ever going through the recovery process, these friends and family members can approve it on the device. The next type of third-party services or gatekeeper services. Imagine an SMS service that sends your text message to verify your ID before approving your recovery request. In future, we see the potential for government organizations to provide gatekeeper services as well. You take your government ID, your government-issued ID, to an office, and after verifying your identity, this government organization can approve your recovery request. Finally, you can use any private key as a gatekeeper. So if you've got a TezBox wallet, a Galleon wallet, you can use a Trezor device or a Ledger device. Any other public key, private key pair can be used as a gatekeeper as well. Now, the final part of the approval, the account recovery system, is the threshold. So as a user, you get to decide how many people need to approve your request before it is finalized on-chain. For example, you can add 5 gatekeepers, set the threshold to 3, and after the third approval has been sent to the blockchain, your account is remapped. This empowers the user to choose the type of security that they want to use with their account. So a big thing we want to focus on is integrations. So we want to actively work with applications, websites, and decentralized apps to allow them to use Sona to work into their existing workflows. Similar to how Facebook login works for websites and apps at the moment. Facebook is used to authenticate a user, and these third-party apps can request access and rights to that user's account. During the year, we want to ensure that we work and establish partnerships with many apps and websites and grow Sona as an alternative to Facebook authentication to provide an on-chain Tezos-based user authentication method. Our system is fully open source, and we've got an open framework, and we want to encourage developers to work with us and help to develop the Sona ecosystem. We're planning on releasing our proof of concept in April. This will run on the Tezos AlphaNet, which is the testnet, so look out for that. And we hope to continue developing the project throughout the year and hopefully release something, a full version of our software later on this year or early next year. Thanks for listening, guys. Save questions for later. You can follow us on Twitter, Medium, check out our code on GitHub. But yeah, it's been great talking. Thank you.